Hi guys and welcome back to my channel. This is episode number 7 of the water cycle and water insecurity unit over here on my channel. Today we're going to be looking into climate change and how climate change can affect the hydrological cycle. So if that's what you're here for, great, stick around. Please do subscribe down below. I upload one of these revision videos every single week, Monday at 4:30 p.m, going through the whole specification. I'll try and remember to link the rest of the playlist up here for you. As I say, it's episode 7. We've gone through the first 6 so far. They're already up on my channel. So yeah, subscribe down below, share it with someone who you think might find it useful, and let's get into it. Good, bad and unpredictable. The climate is changing. For example, unless greenhouse gas emissions are significantly reduced, the risk of winter flooding in the UK is predicted to increase 4.5 times by 2100, and the risk of summer drought by 3 times. Globally, more rain in some places might reduce current water scarcity, but a deficit could result in other areas. Some places are already benefiting from these changes, while others face problems. Climate change affects inputs, stores, and outputs within the hydrological cycle. So, climate change leading to droughts will mean a reduction in inputs, reduce the level of water stored in soil, rivers and lakes, increase the importance of groundwater flow, and cause initial high rates of evaporation. The good, the Sahel. Rainfall is variable in the Sahel region, which forms the southern fringe of the Sahara Desert. The amount of rainfall there varies from 100mm to 600mm per year. The 1970s and 1980s were tough for the Sahel region. Up to 90% of its annual rain falls between July and September, as part of the Western African monsoon. However, in the 70s and 80s the rains failed, with a decline in rainfall of up to 40% between the 1950s and 1980s. Drought, poverty and civil war, especially with Eritrea and Ethiopia, drove many people out of the Sahel onto marginal land. Many people died, particularly in the famine made famous by Bob Geldof's Band Aid in 1984 to 1985. Regreening the desert. The Sahel's climate appears to be changing, although it may just be part of a climate cycle. Since 1996, there have been several wet years in between the droughts. Although the evidence is small at present, it does point to an opportunity for regreening, the conversion for dry landscapes to produce productive farmland. Regreening is a restoration technique that involves planting trees and bushes alongside other sustainable land management schemes. It's popular in Malawi, Burkina Faso, Ethiopia and Niger, where hundreds of thousands of farmers benefit from increasing yields. Regreening is also referred to as farmer-managed natural regeneration. Its benefits include natural regeneration of water, retaining shrubs and trees, low-cost reforesting, and the use of water harvesting techniques. For example, Burkina Faso's farmers build stone lines or dig improved planting pits to trap the limited rainfall on fields and increase yields. The bad, California. Almost 40 million Californians are facing increasing problems due to recent variations in rainfall in the state, which evidence suggests is resulted from climate change. Droughts are a normal feature of the Californian climate, but in 2014, the Sierra Nevada region experienced 3 times the normal number of wildfires because the ground was so dry. Climate scientists at Cornell University are forecasting intense mega droughts lasting 30 years, as well as decade-long dry periods. Climate change is cited as the reason, and already farmers are abandoning their fields. 2015 marked the 4th year of continuous drought in California, the worst in 1,200 years, and water rationing was imposed on cities. Forecasts now suggest a 50% chance of a mega drought hitting southwest California, and a 90% chance of a decade-long drought. 11 of the years between 2000 and 2015 were drought years for the states of Arizona, California, Nevada, New Mexico, Oklahoma and Texas. Combined, these states have a population equal to that of the UK. The drought in these states has 2 causes. Firstly, rising temperatures has led to increased evaporation rates, and secondly, there has been a fall in precipitation. a trend expected to continue during the next decades of the 21st century. If forecasts of mega droughts are true, business as usual will simply not be possible in terms of meeting future water demands. Already, there is evidence of problems. Surface runoff and moisture levels have declined. Forested areas reverted to shrub and grassland. Although groundwater, often used to make up the shortfall in supply, has kept up with the demand from cities such as Los Angeles and Las Vegas, fell by 30 metres between 2011 and 2015. Reservoir levels have also fallen. In October 2016, water storage was 77% of the average for that time of year, but levels varied. Lake Shasta had 102% of the average historical levels. Lake Cachuma, which supplies urban Southern California, was down to 9%. Snowpack, or permanent snow levels, in California in 2015 were at record lows due to high temperature and lack of winter storms. Snowpack is crucial because its meltwater provides 1/3 of the water used by California's cities and farms. Predicting future climate change. Global climate patterns are mainly caused by atmospheric circulation, but ocean currents also play a part. This is shown in the Pacific, where climate fluctuations and extremes can be intense. Normal years. In normal years, Pacific winds circulate around the Walker Cell. Winds travel westwards along the surface of the Pacific, taking warm surface water with them. The cold Peruvian current that flows northwards along the west coast of South America is drawn into the circulation and flows westwards. As it flows west, it is heated by the sun. Warm, moist air rises over Indonesia, creating a low pressure area and heavy rain. The air then circulates east in the upper atmosphere, sinking into the cooler, high pressure area over western South America, giving dry conditions that create Peru's Atacama Desert. La Nina. At times, the normal situation intensifies and is known as La Nina. During La Nina, low pressures over the western Pacific become lower and high pressures over the eastern Pacific higher. As a result, rainfall increases over Southeast Asia and South America suffers drought. Trade winds strengthen due to the increased pressure difference between the two areas. La Nina can occur just before or after El Nino. El Nino. During El Nino years, pressure systems and weather patterns reverse. Warmer waters develop in the eastern Pacific, with temperatures rising up to 8 degrees. Low pressures forms, drawing in westerly winds from the Pacific. Warm, moist air rises, creating heavy rainfall over the eastern Pacific. The air then circulates west in the upper atmosphere. The descending air then creates dry conditions, which lead to drought in northern Australia and Indonesia. The Southern Oscillation Index. The change in air pressure between normal years and El Nino is called the El Nino Southern Oscillation, ENSO cycles. Its strength, direction and speed, called the Southern Oscillation Index, SOI. Meteorologists record the air pressure at Easter Island, west of South America, and subtract it from that at Darwin, in northern Australia, to calculate the SOI. A sharp drop indicates that El Nino is imminent. Most droughts affecting eastern and northern Australia result from ENSO and El Nino. You're just going to have to bear with the rain. We're talking about climate change. Futures and uncertainties. Although El Nino events have been occurring for at least 15,000 years, it is possible that climate change is increasing their duration and intensity. Computer modelling shows that as greenhouse gases warm the planet, different regions of the world will warm at different rates. La Nina and El Nino events will become more extreme, and regions bordering the Pacific will see flood seasons following drought, and vice versa. A Royal Society report used climate models to estimate flood and drought frequencies by 2100. These assume the business as usual approach to climate change and a global population of 9 billion. However, predictions are uncertain. El Nino rarely arrives when expected. Typically lasts 14 to 22 months, but it could be longer or shorter. Further research could improve our understanding of the events of climate change on La Nina and El Nino events, but there is little doubt that ENSO cycles and climate change could significantly impact our future water security. That is the end of episode 7. I hope you learned something. I do excuse the rain, I can't stop that. I'm in a conservatory, you can hear it on the roof. But yeah, I wanted to get this done for you. So please do subscribe down below, and I will see you next week where we're looking at the causes of water insecurity. So I will see you then. Bye guys.